I'm Sarah, and I love proportional relationships because for a lot of years I taught seventh grade, and that's the big theme of seventh grade. And today I want to give you a glimpse into the 2022 Minnesota Math Benchmark 7.371. And I want to particularly concentrate on that first part of the benchmark. I'm going to start by talking about proportional relationships and then a little bit about how they show up in tables, verbal descriptions, symbols, equations, and graphs. So let's look at what happens in seventh grade. It says in our last anchor standard, patterns and relationships, that we should be representing proportional relationships in a variety of ways. But our students come to us already having done that. But in sixth grade, they did that with ratio and rate situations and looked at those in tables of equivalent ratios and did solve problems using those. And equivalent ratios are proportions. So they are coming with experience, and we're going to start calling them proportional relationships in seventh grade. In eighth grade, they'll start to look at linear relationships that are not proportional, and they'll start using the phrase linear relationships and slope. But in seventh grade, we're going to live in proportional relationships. So let's talk about that a little bit. Proportional relationships is a big area. It's connected to lots of things. And so we want to widen in seventh grade what that looks like. A lot of times when we're teaching this, we'll put up anchor charts and they're really good. Here's an example of a really good one. But students will only concentrate on one small thing and then they'll leave thinking that a proportional relationship, they'll have a very narrow view where they think it's a straight line that passes through 0, 0. And they'll go to our assessments, and this is a really low level DOK one question, which one of these are proportional? And because they were have in their mind that a proportional relationship is just something that goes through 0, 0. And that's what they're saying in class. And we're like celebrating. Yes, that's what it is. They'll go to the test and they'll be like, C is proportional because it goes through 0, 0. But then they'll be like, oh, I don't know, which one is it? And you might think, but I've taught them it's a line. Well, let's think about this in a table. A lot of students with a table will say, yes, it has a 0, 0. Therefore, it's proportional. Look at that table. It's going up 0, 1, 2, 3 in the X column. It's proportional. And then they'll go to assessments and they'll be given a test where the items in the table are not even in order. And if you think back in sixth grade, they were learning about equivalent ratios and they're not bringing any of this with them. They're just looking for that 0, 0. So what are we going to do when students say, help, where is the 0, 0? Well, one of the reasons we get here is because we teach a lot of these parts of how we represent proportional relationships in isolation. On Monday, we're like, today we're going to learn about proportional relationships in graph. On Tuesday, today we're going to learn about proportional relationships in tables. Wednesday, today we're going to learn about proportional relationships in equations. And then on Thursday, we're going to do word problems with proportional relationships. And on Friday, we're going to take a task. And hopefully you'll say all of this about proportional relationships. But they're out of like they're disconnected and students are like, I don't know what's up, and they don't see a relationship. So one of the things you want to bring to this benchmark is you want to teach all of these forms of functions together so that students can see the connections that exist. So when they see the constant of proportionality in a word problem, and they're recognizing it, they can connect it when they see a graph, when they see a table, when they see an equation, and when they see it in the way that they describe things. And again, we're not going to rush to use terms like slope. We're going to live in the language of proportionality, the constant proportionality, and talk about that as a rate, and talk about that being a unit rate, and live in that. And so students are coming hopefully with a depth of understanding around equivalent ratios. And we want to make sure that they have that understanding. And then we want to build a definition of proportional relationships where that's something where the ratio between two quantities remain constant, meaning one quantity is always a constant multiple of other. Notice it doesn't say only here line that goes through 0, 0, and that we're giving them rich experiences with this, where they can experience this both abstractly, where it's not in a context, and then also giving them examples that are in context so that they have lots of rich examples and that our anchor charts are grounded in a richer definition when we're doing that. And then speaking of tables, verbal descriptions, symbols, equations, and graphs, we know that in math, we need to be connecting representations of mathematics with our students. And in Anchor Standard 7, the language they use is connecting graphs and equations and tables and context and using the language of the mathematics at that grade level. You notice in this graphic that those arrows in the middle are there, and they're probably the most powerful part of this benchmark because it's super important for our students to be able to connect the items that exist in each of these representations of a function. And on us as teachers, we need to be asking the questions so that students will connect these uh, items to one another. So as we're thinking about that, and the reason we want to do that is because research has shown that strengthening the ability of our students to move among and between these representation improves their growth and students' conceptual understanding. And so as you're thinking about teaching this, it's not just the research from Lesh and Post. That research and many other research forms NCTM's evidence-based instructional practices. There's 8 of them, and one of them is asking students to connect mathematical representations. So as you're teaching this benchmark, I want you to be centering, how am I daily incorporating at least 2, if not more, of these different representations of a function in what am I doing? And how am I asking questions so students see a connection between the elements of each of these things, not just with a constant of proportionality, but other things that exist in this. And then even in 7th grade, you might start to preview what's going to come in 8th grade and compare and contrast proportional relationships, linear equations that are proportional and those that are not. An example from my own classroom was we had this problem about Emil and Henry, and they were going to have a walking race, and the older brother was a little faster, so he gave him a head start, his brother a head start. And so me and my teaching partner, we changed this, and we used her children, Gus and Anya, and we filmed them walking, and we talked about how fast they went. And students solved the problem by building tables. Some of them graphed this, some of them wrote equations. And as they were building this, they were using the language of functions and comparing and contrasting those. So we're in Minnesota, it's fall, it's apple picking time in Minnesota. And I went apple picking, my favorite apple in Minnesota. It's Minnesota favorite is First Kiss. And we picked apples, 4 of us friends, and several of our friends were going to can them. So they brought a lot more and make applesauce. And so we gathered some data about how much it cost us to pick these apples. And the different ones amongst us picked different apples. And again, this is not in order. And so hopefully by the end of this benchmark, students will be able to look at tables like this and ask themselves, is this table full of equivalent ratios? If so, it's proportional. And hopefully they'll start to see relationships, because this is Anchor Standard 7, patterns and relationships that exist. And notice that I can multiply the cost in the pounds that I bought. I only bought 5 pounds of apples, but my friend bought 45, and she paid 3 times as much and bought 3 times the amount of apples. And we can also work backwards on that and see those relationships. And then we can connect that to the constant proportionality. And a tip I would give you in teaching this benchmark is use tables and data that is not just 0, 1, 2, 3, 4, 5, that is spread out, and ask students to look for relationships. And when you make a table, always include a 3rd column where students are calculating that constant of proportionality and looking to see, is there a relationship? Because if it is a relationship, it's not only linear, it's a proportional relationship that is linear. And in this case, a 1/3 of a pound of apples is going to cost $1. That's the unit rate, the constant of proportionality. So as you're thinking about teaching this, hopefully you have some new ideas.